Ahoy hoy, Mr. Nickerson here, and today we're going to learn a little bit about 7.5, which is solving systems of linear inequalities. If you want to get started, take out the packet you received in class, and also you want to have some sort of straight edge, a ruler, an index card, a CD case, something that's straight so you can draw straight lines on this assignment. Alright, let's get started. First thing we got to review is a little bit from what you learned last semester in part 1 is there's two types of lines when we have linear inequalities, and they're either dotted or solid lines. There's certain symbols, inequalities, which result in those lines, and that's what we need to review first. So to begin with, let's talk about which symbols mean which lines. Well, when we have a solid line, that's when we have less than or equal to, greater than or equal to, or obviously equal to what we've been dealing with. When we have a dashed line, that's when we have less than or greater than. When graphing systems of linear inequalities, you're going to have two or more inequalities in one problem. That's going to be important when we go to do the shading. So let's get started. Well, first thing we want to graph both of these. And to graph them, probably the easiest way is to rewrite them so the y is by itself in slope-intercept form. This time, it's already in that form, so we're ready to graph. So we'll start with the first one. Start at positive 1, and the slope's down 1 over 1. Got enough points, I'm going to grab my ruler, use a ruler, and it's going to be a dashed line because of the less than. We have to determine the shading. Last semester you probably used the point 0, 0. So if we plug in 0, 0, zero is less than 1, that's true. So when we get true answers, we shade towards the point that we learned. Last semester, you probably just started shading. Right now, I'm going to go like this and point arrows. And you're going to see why here in a second. Because right now I know if I have two sides here, 1 and 2, that if I have an answer, it's going to happen somewhere over here. It's not going to happen here because of the restrictions on that line. Let's go to the second line. I'll switch marker colors here and switch to black. Start up at 3. Up 2 over 1. Up 2 over 1. I'm going to go down 2 over 1 so I have another point. Use a ruler to connect them. Solid line this time because it's the equal to. And now we want to plug in 0, 0 here. Well, it's 0 less than or equal to 0 plus 3. 0 less than or equal to 3. That time that's also going to be true. So this line is shaded towards 0, 0. Now that we've graphed them both, we've determined the shading of each individual line, we need to see where they would overlap. What parts would overlap? Well, we said at the beginning, if we look at just plain the red line right here, is that because of these two arrows, it's going to happen somewhere in this region here. Because of the black line, we've got two sides in this region. Well, you can see the arrows pointed here, so that means our overall shading is going to happen in this region right there. We've successfully solved our first problem. Alright, let's take a look at example 2. This time, we start off example 2 that they're not in slope-intercept form, and we need to get them in that form. So I'll use the first equation here. Got to get the y alone, move the x over. And then we divide by the 2. Y is greater than or equal to negative 1/2 x minus 1. Let's graph it. Start at negative 1 and down 1 over 2. Solid or dotted line. Symbol tells me solid. Make sure your line extends a little bit, it makes it easier when you go to shade. And now let's test this one out. Is 0, 0 in there? So 0 plus 0 is greater than -2. It is. So that checks out, so we shade above this line. So right now, we know shading, if it's going to happen, it's going to happen somewhere up here above the line. It's not going to happen below it. Our other equation, start off by moving the x over. We can't forget the sign in front of the y. This is a big part that some of you may have forgot from part 1, is what happens now when we isolate y, when we divide both sides, or multiply both sides, by -1. We need to remember that rule is that when you divide or multiply both sides of an inequality by a negative number, the inequality flips. So this becomes y is less than positive x minus 1. Start at positive, or -1, excuse me, up 1 over 1. We can connect those points. We know it's going to be a dashed line. And when you check it, still check it in the original. 0 minus 0 is 0 greater than 1. No, it's not. So we don't shade towards 0, 0. We shade away from it. And you can see where are these going to overlap. We said it would overlap somewhere on this side. It's going to be here because of that arrow. And there's our final shade. Alright, let's talk about example 3 a little bit. First thing, I looked at my first equation, and I needed to get in y by itself so I could graph. So I first subtracted x from both sides, and then divided everything by -1. Remember, when you're dividing by a negative to both sides of an inequality, that the inequality flips, and we get y is greater than x plus 1. So if I look here at my graph, there's my line. And then I tested with 0, 0, so is 0 less than -1? That's not true, it's false. So I said it would be shaded not towards 0, 0, but away, so it's shaded above. My next equation, x minus y is greater than 3. Subtract over the x, divide by -1. Inequality flips because we're dividing by a negative. Y is less than x minus 3. Test it, and I get is 0 greater than 3. That's false. So it's shaded not towards 0, 0. So if we look at our graph this time, there is no point that will intersect. Because they're shaded opposite directions, we're looking for the overlap. There will be no overlap. So this answer will simply be no solution. Alright, let's look at the final example. And for the last example, example 4, first I started off by solving my first equation there in red for 2x plus y is less than or equal to 4. Just move the 2x over. Some people start thinking every time they move a negative over that the sign flips, but it's only when you multiply or divide. So remember that as you're going. And once I graph that, you can see here I have y is less than or equal to -2x plus 4. And that when you plug in the point, 0 is less than or equal to 4. That's true. So I shaded or put my arrow towards 0, 0. My next line, I first started by solving for y, and when I solve for y this time I do have to worry about that negative. My final inequality would be y is less than or equal to 3x minus 6, and 0 is greater than or equal to 6. That's false. So for that line I shaded or put my arrow away from 0, 0, and now where do they overlap? Well, right in that section at the bottom. This concludes graphing linear systems of inequalities. See you later.